Good morning, good afternoon, good evening, everyone. Welcome to the Data Integration Leader Series webinar, where we explore cutting edge strategies and insights in the world of data integration. My name is Avinash. I'm co founder and CTO at Nextla and host for today's session. Today, we are joined by three amazing speakers: Nikita Kovstals from DoorDash, Abhishek Jain from LiveRamp, and Daryl Cherry from Clearwater Analytics. We'll explore the key challenges and solutions involved in implementing real time data integration at speed and scale. Please submit your questions throughout the sessions and we'll answer them live.
To kick things off, I'd like to introduce our very first speaker, Nikita Kovstals, who is most recently Director of Engineering at DoorDash. He has helped scale the grocery marketplace to a multi-billion dollar GMV at DoorDash, and he was a co-founder at EcoRebates before that. Without further ado, let me hand it over to Nikita to talk about from noise to value.
Hey everybody, thank you for joining. My name is Nikita. I've been building software as an engineer, founder and engineering leader for over 20 years. Today I'd like to share some of my observations and lessons from building data-powered products in retail, payment, and marketplace spaces. Just a little bit about me. I love technology. I love the internet. I like the idea of borderless commerce behind the internet or the internet enables. My career, and very briefly, I started out at Sun Microsystems last century. Went on to start in direct-to-consumer digital marketing company called EcoRebates. That's still around 14 years later. Then went on to work at Stripe on payment infrastructure. Hopped over and worked at DoorDash, launching expansion from food to grocery delivery service. And the last few months, I've been taking some time off and considering what's next. If you're interested in connecting, my LinkedIn profile is on the slide. Let's talk about product data a little bit. As probably not surprise to any of you today, software products at their core are some combination of design, code, and data. An app looks a certain way, it functions a certain way, and at the end of the day, it sort of operates on some amount of input and output data. Therefore, you can think of the quality and scale of data as sort of an upper bound of the quality and value that the product can provide. If the data is poor or insufficient, chances are a product is going to have an inferior or somehow unsatisfying user experience and therefore be less useful. So data has a huge impact on the final quality of the product or internet service. And of course, there are plenty of challenges in data. First of all, oftentimes it's hard to come by. It's not sort of easily available. It must be acquired or generated or transformed in some way to fit a product uniquely, perhaps. Data can be expensive or difficult to acquire. Not so easy at Stripe when we were building. Oh, sorry, I have to restart the slide. Um, let's talk about product data. Software products at their core today are some combination of design, code, and data. They look a certain way. There is some code that performs some function, and at the end of the day, the product usually functions by ingesting and operating on some data to produce some output for a user. The quality of scale of data is a huge determinant in the overall quality and value of the experience that product delivers for the end user. But of course, there are also some challenges with data. It is often difficult to acquire. It's not readily available. It must be somehow transformed or generated to fit the needs of the product. It could be the sources of data could be often ephemeral, as in they exist today, they don't exist tomorrow. Oftentimes, in order to produce a product data set, one has to source data from multiple places and then kind of join and make it work together. The way of acquiring data might vary. Some data sources might offer you an easy to use API. Others are a lot harder, all the way to calling people for data, or perhaps scraping data off the web or some other way. Once you've acquired input data, it's often difficult to resolve identity across multiple sources. Say you're collecting product data, different data sources might describe it differently, and understanding which two records from two sources refer to the same versus different thing may not be simple. And lastly, it might be actually difficult to understand or evaluate quality of data. That is both the data you want to ingest to produce a product data set as well as the final result. Is it any good? Hard to tell. All of that obviously impacts the final quality of data that is fed into or operates on the product, and therefore serves as sort of an upper bound of how good or valuable the overall product and product experience is. So it's a challenge and an opportunity at the same time. Let's look at a couple of examples from products I've built in my prior experience to kind of motivate our discussion. I worked on card payment costs at Stripe, where a payments company wishes to report transaction level fees that the merchants are charged by card schemes and financial institutions. That data is not readily available, and so Stripe has to compute or infer what kind of fees apply to which transactions and provide kind of a breakdown for their users. In another situation, a grocery delivery marketplace wishes to sell and make it easier for consumers to shop groceries from their local merchants. Obviously, a key part of shopping experience is vast selection of products one might buy, as well as rich information about those products to help users make informed buying decisions, like photos and descriptions and taxonomy of products in a very large product catalog. A couple of considerations when curating a data set. So whether we're building a data set of fees on credit card transactions or data set of grocery product information, we want some combination of comprehensive, accurate, and available data. That is, if you're shopping for groceries, more products are better than fewer products. Richer data set about a product, more metadata, more descriptions, more photos is better than fewer. The data must be obviously as accurate as possible, and it has to be generally available. That is, when your product functions, when your app runs, you want data to be there to serve to the end user. Above all, or in addition to that rather, data has to be produced efficiently for a business to make sense, especially large data sets can be very costly in terms of time and dollars to curate, and of course, efficiency a huge factor in success of a product. Couple of words on measuring data or measuring quality of data sets. Typically, there are two types of metrics. A North Star metric, something like selection of a catalog, where more is generally better, and a company strives to build as large a catalog as possible or as rich as possible. And there are more operational metrics or SLAs that speak more to sort of error rates or efficiency of serving data sets to the end user. It's important to note that the thresholds of how much data is enough or how efficient of a serving solution is efficient enough has to be dictated by kind of a user needs or product goals. So it's not necessary to always strive for more, better, faster. One must consider what is important in the user experience. Just a couple of brief overview of how, at least in my experience, data is produced. What's a typical flow or conveyor belt, if you will, in producing a production data set? Well, we start by looking around and trying to find some source input data. For example, in building a product catalog, one might go to brands that manufacture products and ask for data they have, or work with partner retailers to source data. Oftentimes, again, one would source data from multiple sources and kind of splice together a superset or an intersection of data as a final product data set. Once you have identified your sources and you need to ingest the data, that has its own challenges, as I mentioned previously. The availability of data sources, how easy it is to sort of ingest the actually transmit data from source to your app, how structured or unstructured the data is. All of those things vary, and oftentimes the answers are sort of all of the above. Data sources come and go. Often your product outlives the set of available data sources, and so it's important to be nimble in being able to ingest data quickly from new sources, and as well as monitor its quality. Once you've ingested the data, it's important to be able to, as I mentioned, kind of resolve identity. That is, oftentimes records pertaining to the same thing, the same product, are sourced from multiple locations, multiple sources, which might use, for example, different identifiers. And so understanding that the same product is described in two different data sources, might be described differently, but is actually the same product, is actually a very hard problem. Then you might typically want to mine input data for attributes that are relevant to your product, sort of descriptors, kind of maybe a brand describing a product, price point, availability, etc. You have to have a way of verifying the final product of kind of modeling or extracting attributes out of the raw data that you receive, some way of serving data back to users, and equally importantly, then monitoring and detecting or instances when your data is, the product data that you serve up to users is invalid in some way. We'll speak to what that means in a second. So a few lessons I've learned through sometimes bitter experience of building these product data sets and going through the journey of kind of creating products that powered by said data. First, in my opinion, it's critical to understand and segment product needs, or sorry, customer needs. The resources and the time one has to build a great product are obviously limited, and so it is very important to develop a visceral understanding of what the users are trying to do, what problem you're trying to solve, and articulate a product vision that can help clarify trade-offs between what must be excellent and what must be merely good enough in a product in order to help users achieve their objectives. That understanding then helps product developers and product designers develop, for example, nuanced SLAs, where is data quality, for example, must be excellent. Say you're building, again, sort of a billing reporting product, the accuracy of numbers or allocation of fees obviously is highly important. You must not, your financials at the end of the day must reconcile, and so the dollars and cents have to be just right. Whereas perhaps the quality of photos in a shopping product, while important, maybe have a little bit more tolerance for how sharp the images are, but at the same time, you may not show a banana when you're selling an apple. So the thresholds for what is good quality are informed again by the user experience. Your data models obviously need to be extensible. Again, in terms of thinking about what is important in a product, you might start out with a kind of a fairly general unsegmented data model, but then find kind of the subset of let's say products in a product catalog that have to be much more descriptive and have much more attributes because of the sort of how immersive user experience we want to have in a particular segment of use cases. So it's important to understand what consumers' needs are, have an opinion of how to prioritize them to then inform how your system is built and how you go about the fidelity of data, sort of developing the level of fidelity of data in your product. It's important to assume that, as I mentioned before, kind of that the sources of input data, that which might be many and different, will rotate over time. And more often than not, I found it very important to be able to deal with onboarding new data sources as efficiently as possible. Efficiency, when I speak of efficiency, I mean two things largely. One is linear time it takes to onboard a new data source. Can you do it in a day, in a week, in a month? And secondarily, who can do the job? Many companies have both engineering and, say, operations departments. In building a new product, oftentimes engineering becomes a bottleneck. So it's great if you can minimize engineering cycles or time is required by engineers to onboard a data source, and kind of shift any operational burden to non-engineers or an operations team to be able to reach effectively higher overall product velocity. In the case of building a grocery marketplace, we found using a Nextla solution to be extremely helpful in that regard. We swapped out kind of a legacy bespoke data source adoption workflow that we had internally that required basically custom code for every data source with a Nextla platform. And there was, as a result, roughly what is this, about the 15x speed up in amount of time it took to onboard a data source, in which case, in our case, was typically, again, a brand or a merchant selling a set of products. So we went from taking 5 or 7 weeks to onboard such a data source to 1 or 2 days. More importantly, who did that switched from engineers who went on to build features instead, or systems pertaining to core product functionality, to instead operators that were able to use, in this case, a Nextla system, or basically a configuration-based system to onboard and monitor data source ingestion. One more lesson, typically on needing to pause. Finally, a word on efficiently evaluating data quality. With both input and resulting kind of product data sets, it's often very difficult to initially assess how good data is. Particularly with input data sources, you might find that for your use case, there are 15 possible places where you could source data. What is difficult is to figure out how comprehensive and accurate that data is. So the more one develops a mechanism of efficiently evaluating both input and output data sets, the faster or the higher your product velocity will be. And you spend less time sort of theorizing about how good this data set is, and more time building the product that this data powers. So how do we do that? How do we evaluate data quality efficiently? Again, it starts with understanding requirements and thinking about what is important in the data set. I love the idea of feedback loops, particularly of the passive nature. That is feedback loops that are naturally occur in a product as a consumer or user uses your product. The actions they take might imply pretty directly their happiness with a data set that they've or a piece of data that they've been presented with. A classic example might be sort of a list of search results. A user sees 10 links, they click on a third one, probably means that the first and second one are not very good. Or if they visit a web page and come back and go to a second result, again, you know that behavior indicates there's something lacking in the first or second result. So that's an example of a passive loop. Look at your product, think about where user experience or user behavior might indicate effectively a piece of feedback about the data they're seeing, and instrument your product to feed that signal, those events, back into your system to retrain your models or change the rules if you have business rules that act on data and produce it in some way. Golden data sets are great, particularly if you're doing some machine learning or AI to generate data sets. When you produce a data set, you want to have something to compare the output to. Is your model producing better results or worse results? If you can curate a data set that's excellent, whether it's sourced from users, as in that would be sort of least expensive, all the way to staffing an operations arm that does nothing but labels data for a living. That can get pretty expensive, and do watch out for human error itself, meaning don't look at human curated data set as gospel. That data set will have errors too. Some of the ways to reduce errors of human curated data sets is basically investing in as simple of labeling tools as possible. If you can do something that says, right or wrong, build a tool that provides two options to a human evaluator, big buttons, right, wrong, left, right. That reduces the chances of human error. When errors persist, you might want to resort to something like voting, where you'll have multiple evaluators look at the same piece of input data and make a decision, and then kind of trade off or vote their results to decide whether or not the final decision is A or B. Well, there you have it. Thank you very much for listening. I was happy to share my experience, and wish you the best of luck in building your products and delivering great value to your users.
Nikita, that was a great session. Moving on to our second speaker, it's my great pleasure to welcome Abhishek from LiveRamp. Abhishek has seen LiveRamp evolve over the last 15 years. 15 years back, there was no Databricks, there was no Snowflake, there was no generative AI. And Abhishek has essentially seen this wave of how data landscape has changed in the last 15 years. Abhishek is going to talk about how do you scale data integration challenges, and LiveRamp is a perfect example of that. So without further ado, let's move it to Abhishek.
Thanks for the warm intro, Avinash. As Avinash mentioned, I'm Abhishek, one of the engineers here at LiveRamp, been with LiveRamp for over 15 years. Currently, I work at LiveRamp as an architect. So quickly introducing about LiveRamp. LiveRamp is a data collaboration platform. We offer flexibility to our customers to collaborate wherever their data lives, within organizations, across companies, and across a whole bunch of partners. Now, we also help our customers solve some of their biggest data challenges, such as connecting their siloed data sets. So, like navigating the whole ecosystem in the with the third-party cookie deprecation that's looming, and then also with the cross-cloud interoperability, and all of that in a privacy-centered manner. Now, with all of those capabilities, we empower our customers to improve the consolidation of consumer touchpoints so that they can build a holistic consumer profile, what we call like an enterprise ID, securely activate audiences so that they can reach those users in the appropriate platforms in a privacy safe manner, and then also achieve like high quality measurement and attribution insights so that they can get a better return on their ad spends. With all of that, the ultimate goal is to improve our customers' journeys so that they get the relevant content, whichever application they're consuming. Quickly talking about like the scale that we operate in, we handle about 50 petabytes of data on any given day. That's the raw storage that we handle. In order to consume and process that data, like our overall cluster across like all of our systems and applications, that comprises of around 90,000 CPUs and like 300 terabytes of memory. On any given day, we process about 150 billion of rows that, for processing those, we use like Spark heavily, and that's like around like 100,000 Spark pipelines or jobs any given day. And we also send the data out. So that's about like 250,000 API calls roughly at any given time. Now, very quickly looking at our data processing architecture from a 10,000 foot view, just to give some context, we process a variety of data. That's like first party, second party, or partner data. Now, this data includes CRM data, real time signals, including transactions, impressions, etc., that our customers or partners own. We enrich that data with LiveRamp's identity graphs using batch and real time processing using Spark and Hadoop. And this processing then transforms the data sets, making them usable at hundreds of downstream applications serving different use cases. And some of those use cases include audience activation, measurement, attribution, lookalike modeling, etc. This is just to set some context on what LiveRamp, how we solve it at LiveRamp at a very high level. Now, for the purpose of this talk and relevance to this webinar, I'll highlight a few technical challenges that we have faced over the years and how we have solved those. And hopefully, this will resonate with some of the folks in the audience and can help them in their own journey. Now, there are two core areas that I'll focus on: challenges related to scale and integrations. So, talking about scale, as mentioned earlier, we process petabytes of data. Now, this processing involves ETS jobs for data preparation, hygiene, data normalization, massive joins across different data sets, etc. Now, we've created a ton of libraries and services to support these capabilities at scale. And given the massive volume, we leverage Hadoop and Spark pipelines, and that gives us the throughput that we need. Now, with that kind of scale, we need to make sure that our processing costs are contained, both at the infrastructure and at the application level. Most of our processing is on Google Cloud Platform, so we all of our systems run on GCP, and we leverage. One of the things that we do is like we leverage Spot instances anywhere and everywhere possible. Especially for our Dataproc clusters, as much as possible to reduce our costs. We also use elastic scaling on these clusters so that we only pay for what we need and when we need it. Another key optimization that we have done in our application layer is that we use checkpoints in our data processing. This gives us the ability for our jobs to resume where we left off in case of failures and retries, avoiding a ton of reprocessing. So we have also used a lot of orchestration to support with these failure handling and retries, such as temporal and cadence. So that helps a lot here. Third is resource allocation. Now, we have a variety of customers ranging from enterprise retailers and brands to large data providers. And we need to make sure that we allocate resources appropriately across all customers and don't starve any of our customers for resources. For this, the application layer, we have added support for throttling. We use prioritization in our job queues so that higher priority jobs get resources appropriately. And last but not the least is compliance, and that is core to everything that we do. Given the kind of sensitive data that we process and like the kind of data that we handle, we have to solve it at scale. This involves following GDPR, CCPA, and other state regulations, as well as staying on top of these challenges. Like handling at the scale that we do, adding support for compliance and all this is taking scale to another level. Next, I'll talk about integrations. This is another of our core assets at LiveRamp that we have developed over the years. We support over 600 or so integrations to numerous applications, cloud platforms, data lakes, warehouses that our customers use. Now, first of all, as you can imagine, developing and maintaining these integrations has been an enormous undertaking over the last 1.5 decades. Each integration is unique and has its own eccentricities. Now, when we started on this, like there were not many technology partners out there doing this at scale. So out of necessity, we developed these capabilities in-house, and we continue to invest a ton in this area. Now, another issue when integrating with partners is partner rate limits. The way we have handled this is by supporting expandable infinite backlogs or job queues, so that when we have massive amounts of data to send out, we can handle those gracefully. And last but not the least, fault tolerance becomes critical when integrating to external systems. Now, this is to make sure that we don't incur any massive reprocessing costs due to external factors like a partner API going down or not available, and to make sure that we don't miss any data. Now, we have solved this by adding and automating some like smart retries to reduce on-call production issues, as well as needing any human intervention. Now, that was about where we are today. Like talking quickly about the future. Now, as we and the future is like we want to. So this is where we are today. Now let's talk about the future. Now, as we embark on the journey to create a premier data collaboration platform, our strategy is anchored in leveraging the best of what the industry has to offer. We are building on a foundation of industry standard software products, ensuring that our platform is both robust and cutting edge. Now, these strategic collaborations with partners with industry leading technology partners are pivotal as they allow us to focus our energies on solving the customer specific problems rather than reinventing the wheels and reinventing existing software components. Now, this approach ensures that we are always adding value where it matters most in addressing the unique challenges and needs for our clients. And with that, thank you. That's all I have.
Abhishek, that was a great session. Thanks for doing that. Let's do a quick sort of Q&A. You talked a lot about uh, you having to deal with huge volumes of data, the petabyte scale. There is huge amounts of variety from the sources that you ingest data. There is similar amount of variety on places where you can activate that data. The volume of data is always increasing. So as we call the three V's of data at scale, in your experience, what has been the hardest challenge to deal with here in terms of time to implement, time to market versus handling the scale of data?
Yeah, good question, Avinash. I would say actually, like, the challenge has been handling all three at the same time, right? You mentioned like the speed of data, the volume, and the variety. Like handling all of those three at scale has been the biggest one. If I have to pick one of those, I would say variety of data will like stands out. We have around, like as I said, like 600 or so integrations, like both on, like, where we import or ingest data from, and also where we send data to. And I mean, this well, like, like each integration has its own uniqueness, like how they format the data, how they encrypt it, how they compress it, and what the APIs look like, how we authenticate with them, all of that. So if I had to pick out one of those, I'll say like the handling the variety aspect of data integrations has been the most challenging. And this is what I was saying earlier as well, is like, this is where we have invested a ton of time over the last 15 years, and we continue to do so.
And it just gets more and more complicated because there is a new API version that comes out.
Yes,
Somebody goes and adds a new field on the input side, and it just gets more and more complicated to deal with the variety.
absolutely, absolutely.
Uh, I mean, very quickly, you talked a little bit about third-party cookie deprecation, and there is a lot of talk about that in the advertising landscape. How does that impact us as sort of the data team? Does it make our jobs harder? How does that impact us?
Yeah, no, that is, absolutely top of mind for everyone at LiveRamp. Like I mean, just for the context for the audience, like Google is deprecating third-party cookies end of this year, and LiveRamp being in the ad tech business, like a lot of ad tech companies, like the whole ecosystem is like thinking about it right now. Now there are two areas where it affects, I think, like, data teams and data engineering. One is, like with third party cookie, like, and like how the whole ad tech ecosystem works, like third party cookie is the de facto currency for collaboration. And with that going away, companies have to find other ways to collaborate. So I think we are starting to see this, where there's a lot of one-on-one collaboration happening. So the amount of like collaborations in the industry that we will see is just going to explode over the next year or so. So that's one hypothesis, and we're starting to see some of that already. And the second thing is like the cookie being a transient pseudonymous kind of identifier. And with that going away, there's a lot of emphasis on using like first party identifiers, and which are more sensitive, which are more persistent. And so the needs for governance, the needs for privacy preserving techniques, and the tools like data clean rooms, that at scale, that increases because now we're dealing in, like, more sensitive data than ever before.
Absolutely, and then you also need more compute power to process this. So sort of those back in some ways to your volume and variety and velocity of the data, because now you need to handle all of this at a much bigger scale.
Yeah, absolutely.
I have one future-looking last question. You probably have to live under the rock to not hear about AI and generative AI and things like that. How is that impacting the future of your work at LiveRamp?
Yeah, I mean, it's like a conversation or a day doesn't go by when we don't talk about it. It's happening everywhere. So there are two areas where two streams like that we're thinking in for AI. One is for improving our internal productivity and operational efficiency. So using tools like, whether it's ChatGPT or Copilot or things like that, to improve like development productivity, operational efficiencies, etc. And then we are also working and like putting a lot of thought and emphasis on how we can leverage AI to improve our customer experiences, like when they are using our products. And so, how can we make our products better, leveraging AI? Some of the AI techniques. So whether it's like improving the using like techniques like vector searches, etc., to improve how we build like our identity graphs, or using AI to do better data classification, etc. So those are some of the examples and some of the things that we actively pursuing.
Great. We're completely out of time. Thanks for doing this, Abhishek. I'm sure there are more questions coming our way for everybody on the chat. If there are any questions that you guys have, please put it on the chat window, and Abhishek and I will try to answer as much as we can. Thank you.
Cool. Thank you so much. Yeah.
Thanks.
Let me now hand it over to our next speaker, Daryl Cherry from Clearwater Analytics. Daryl has been a leading innovator in space. It's about 19 US patents to his name. He's been doing this for last 25 years, and you'll love to hear from him as he talks about Gen AI and how Gen AI intersects with data.
Okay. Thanks, Avinash. So I'm Daryl Cherry, distinguished engineer at Clearwater Analytics. I've been at Clearwater for a little over 4 years now, but been in the industry for over 25 years. I'm in the CTO office, and so I lead our generative AI strategy and technology, as well as enterprise architecture for Clearwater. And for those who aren't familiar with Clearwater Analytics, we're a public fintech SaaS company that does investment management and accounting. We report and aggregate and reconcile over $7.3 trillion in assets under management. Our reconciliation is over 90% fully automated. And we have 13,000 plus users on our multi-tenant SaaS system. Our net promoter score is north of 60, so our clients really love our products and services, and we love our clients. It's what drives us, and it's our passion. So with that, let's talk about generative AI. So this is a press release that Clearwater did recently, about 3-4 weeks ago, announcing our Clearwater Intelligent Console. So this is what we're calling Quick, and we have a Quick family of products for the different products that Clearwater offers, and it integrates generative AI solutions into those various products. So with Quick, we really have 3 effective capabilities that it can do. The first one is knowledge awareness. So it understands what Clearwater does, it understands how Clearwater operates and does accounting, and all the different things that our customers are calling to ask questions about. Quick will know the answers. And so they can use Quick, get the answers very fast, very quickly, and be able to be on their way to do their business. And they don't have to wait for customer support or long times in exchanging emails. So that's one of the big pillars of our initial Quick release. The second is our application awareness. So the application awareness is where Quick understands the application that our user is operating in. So if they're looking at different reports and they're trying to find something, they can ask Quick where this particular report is. If they want to say something like, what's my exposure to Germany? They can ask that to Quick. Quick will look what reports are available, and it can show them a link where they can click. They'll say, this is your international exposure report. And then I'll give them the list of different exposures worldwide. The third element with Quick that we're looking at is, and this is one that is under development currently, is data awareness. And so in this particular pillar for Quick, this understands not only the application the user is in, but also their data and how their data is being presented in the report, how it's being used. And so now, besides asking questions about Clearwater in general and the applications and the accounting or the applications and reports, they can ask questions about their data and get answers for how is something calculated, how does the book yield tie out, those types of questions that rely on the data underneath to answer what the customer needs. So this is a high level of our platform. And this is really what we're at now in terms of a generative AI system. But it's important to rewind back to the beginning. And so the beginning was about a year ago when our CEO got a core group of us together and asked us to look at generative AI and how we can drive that into our business and our solutions and our products. So that core group, we had 3 work streams that we were running on. We said, okay, the first thing is let's do an ideathon in the company. Let's find out from our domain experts, our subject matter experts, what are the biggest problems they're facing and how do they think generative AI could help them build solutions. And with the ideathon, it gave us, I think we had over 300 ideas. And we narrowed it down to about 10 that we thought were the really high value ones we should pursue. In parallel, we started building an organization around this. So we started getting lots of different folks, interviewing, building out a generative AI organization in Clearwater that'll look at implementing those different solutions that came out of the Ideathon. And the third was creating a ChatGPT clone. So Clearwater, like many companies out there, when ChatGPT was announced, CISOs around the world lost their minds because different companies were putting sensitive data. Employees would put data in ChatGPT, and that point's in public domain. So we had our InfoSec came out and said, "Thou shalt not use ChatGPT for any company data." So that was one useful tool that seemed really promising that now the company didn't have at their disposal. So we wanted to create a clone for that, something that was private, that was secure, that all of our teams could use and use for their business and get the advantages of the efficiency gains ChatGPT could provide them. And so we released the first version of that in about 3 weeks, and our teams started using it, customer service, operations, and found extreme value in it. It was using the same GPT models that ChatGPT was using through Azure. And so that led us down this journey and this path of building this platform. So we called that tool Crystal internally. And Crystal was a full tool with this platform included, but as we evolved it, we pulled it out, created this horizontal platform that we could build other solutions on top of. And Crystal remained as a vertical solution for our internal teams. Quick then was developed as an external tool on this platform for our customers. And that's how this came to be. As you can look at the bottom of this, vector databases and retrieval augmented generation really powers this system. And we have internal tools where we have LangChain and other things where we can access data inside of Clearwater. And of course, the prompts are a key element to this as well. We have system prompts that really guide what the users can do and how they can operate. We have prompt templates that help our systems and our teams like operations and customer support do repeated processes and just put the data in. And then the user prompts. So anybody that's using the system, be it an internal person or customer, all that comes into the system. We use our RAG databases and our tools and then pass all that information to the LLM to get the right response for our customer or for our internal teams. And I'll go into some detail here around these different components of our platform. So the first area, retrieval augmented generation, like I said, this is a very fundamental part of our platform. And this is really making LLMs even smarter. So they're already pretty smart. LLMs, if you looked at GPT-4, it's passed the LSAT, it's passed the GRE exam. So it's pretty smart, but there's things that it doesn't know. So before we talk about some of those different things, let's look at the mechanics of what RAG does. So with the vector database, everything, even though it's large language models and you can have it write poetry for you, you can do essays. At the end of the day, it's all math and it's all vectors. And so what we do is we take a knowledge base, some source of information that we want to add to that large language model's knowledge, and we vectorize it, we embed it. And that puts all these different math vectors, transforms that text into math vectors, puts it all in this database. And then when somebody's prompting our system, we take that prompt, we embed that into vectors, and we do a query against this vector database with the prompt vectors. That pulls out a bunch of semantic similar searches, things like approximate nearest neighbor or algorithms that are used to pull related information. And we pass all of that information into the large language model. And it uses that to go and understand what the context is and what we're asking and provide us a solution. So here's a real example in Clearwater of how we use RAG. So in Clearwater, we like to name our systems after Greek mythology. So we have a system called Helios. Now, it's Greek mythology, so large language models, they know that, they understand it. So when I ask a question, what is Helios? It tells me, oh, it's the personification of the sun god in Greek mythology. It's depicted as handsome, so on and so forth, and gives us all the information about Helios and what it means in Greek mythology. Now, in Clearwater, Helios means something different. So when we take our knowledge bases and our RAG systems and we enable that, now we ask it the same question, what is Helios? And it tells us Helios is an internal data reconciliation tool used by Clearwater Analytics. And it gives us all the information for what Helios is and does and how it's used. One other key element here in RAG are the citations. So this gives us explainability. Now we see all the different links to where it got this data from. So not only are we seeing the answer to our question, but we now see the sources that were used to develop that answer with the LLM. So it lets the user go back and they can search and make sure that these things are accurate, and it gives them confidence in using these different responses that the LLM gives us in our system. So this is a high level or advanced RAG system. Now we took that, let's supercharge this to say, let's RAG things on the fly. So now this gives us the ability to take a document, a large document, medium document, whatever, upload it into our system, and then our system will vectorize that document, store it in the database, and now we can ask questions about that document. We can ask it to do summarizations, we can extract data from it, lots of information now that we can use with a document that we didn't want to read or didn't have time to digest, or we wanted to use it as a knowledge source to ask various questions. So just like the RAG system, as we prompt it, that goes into the embeddings and the vector database query. We get information from that document. It goes into the LLM and generates that response. And we've used this quite successfully. So here's an example of what we've done in Clearwater with that document advanced RAG system. So we have different policies that come. These are investment policies from various customers. They're documents. They give all the kinds of constraints that that company uses to invest their money, and what kind of stocks, what kind of assets, those types of things. And so we uploaded this document, and I highlighted a few areas here. We can ask questions now. So I uploaded it and asked a question, what's the maximum investment in a single preferred stock? And it comes back, says it's no more than 3% of total admitted assets. Ask another question, what kind of fixed income securities can I invest in? And it comes back from the document, you can invest in NAIC Class 1 or Class 2. And ask another third question, how much cash should I include in my portfolio? According to the document, you should have at least $500,000 in cash or cash equivalents so that you can have sufficient liquidity. So it pulls all this information from the document. It can answer any questions that we have. So next one's around tooling. So as we saw in that overall document, we had tools that were also on top of the platform. So we have the knowledge bases underneath, we have the tooling on top. And this is really about making LLMs more capable. So they can do lots of things, but there's some things they can't do very well. So now you can introduce tools to fill those different gaps where the LLM can't do certain things. So in this example that I'll show here, we created a search tool and a date calculator tool. It's a contrived example, but it's kind of fun. The title and description are very key. So if you're using LangChain or a tooling foundation platform, you can now provide the description in very good detail so the LLM can understand which tool it should use based on the question and the prompt that the user is asking. So in here we have, like I said, a search tool, a date calculator tool, shows the schema that the LLM needs to communicate with that tool and how it should get the data in response. So here, this little example, we have the user ask a question, how long was the latest Matrix movie released after the original? So the search tool is going to go out and says, I need to use that tool to get back the release dates. So it uses the tool, gets back March 31st, 1999 for The Matrix and December 22nd, 2021 for Resurrections, which is the last one. And now it uses the date calculator tool because it has two dates. It needs to know the difference. Let's talk to the date calculator tool and give it those two dates. And we get back 22 years, 8 months, and 23 days. That lets the LLM now take all that information, formulate a proper response that says The Matrix Resurrections was released on 12/22/21, which is 22 years, 8 months, and 23 days after the original Matrix movie was released on 3/31/1999. So just an example of how the LLM can understand the question being asked, understand what tools it should use to get answers to those questions, and then provide a really good response. So this is a real example in Clearwater of what we've done with LangChain and using tooling. So we have a tool that we've developed called Available Reports. And if you recall what I mentioned with the query for what's my exposure to Germany, that was an example of using this Available Reports tool. So here we can ask it a question while we're in the application. We say, what's my cash balance by position? And so what that does is it knows that we have a number of reports, and it can look through those reports and say which reports match that question that's being asked. And it finds two, gap balance sheet by position and stat balance by position. And so it now gives us links, and so we can navigate in the application directly by just clicking those links that the LM has responded in quick with. And that is effectively a way for us to take novice users of our system who don't know the ins and outs of everything. They can ask questions and navigate just like a power user. So this has been a really big advantage for our customers, and they've given us wonderful feedback about it. Okay, so fine tuning is another thing that we're looking at. This is really making LLMs more specialized. And so here, models come in many sizes, right? You have GPT-4, which is a very large model, trillions of parameters. And then you have smaller models like the 7B Mistral, Llama 7B, other ones that are smaller and they're cheaper. So the GPT-4 models, like we said, they're very smart. They can pass the LSAT. But do you need a model that can build poetry for you and do all these things? Or do you need a model that can just run your task and do what you need to do? So this is where the option will be something that you need to decide based on your use cases that you have to solve. So one model to rule them all, that gives you the GPT-4 example, very expensive, or smaller specialized ones to the task. So at Clearwater, we started out with the GPT-4 models, the bigger ones, but we're also looking at how do we fine tune and do smaller models, because that's going to be much more cost effective for us as we scale this system with all of our different customers. And we want to have extra specialties like regulatory specialties, accounting specialties. So data is paramount for fine-tuning. So as you do this, and if you go down the fine-tuning path, you really need to curate and have large amounts of data that you can use to do that training. So that's a very important point. Even in RAG systems, you want to make sure that your data is very curated and is clean as you're putting it in your system, because that's what the model is using to answer the questions for your customer. There's two common models used in fine-tuning, prompt and completion pairs, where you have examples of prompts and completions that you use to train the model. And the other one is domain adaptation, where now I can just take different documents and I can add that to the knowledge of that particular large language model, and then it can use that knowledge that it's learned to answer questions. So productionizing generative AI. So this is another key element here. So as you're building these cool tools and you can do lots of great things, how does that translate into putting something to production that your customers can now use and you can trust with them? So validation and regression testing are key. Just like regular code, you have unit tests you can go through, and it's very deterministic for what you're doing. But when you're using a large language model, I can put the same prompt in and my response can differ every time. Even though it's really meaning the same thing, the exactness of that response is going to be different. So it's not deterministic like a unit test capability. So in here, what we've done in Clearwater is we set up a system where we have a test framework that has known good prompts and known good responses. So now we can run through that known good prompt, get a response, and then have the test framework use another LLM to compare those responses and give us a similarity score based on how we've structured it. And then we get a response of a pass or fail from the test framework. And that's how we know if the system is regressed properly or if there's a problem and something's changed. And we've seen this as we've altered system prompts, where we've changed the system prompt, and that effectively changes the whole prompt going to the LLM, and our response came out different than we expected in a lower quality prompt. So this really helps us make sure that what we're doing, any changes we're making, don't impact adversely our customers or other internal people using the system. Monitoring and alerting is another very key one. You have to, when you're running a production, you need to monitor and alert on the system. If something goes sideways, you want to know right away. And having full audit trails is very key. So every prompt and response that comes into the system, we're logging that. So if something does go awry, we can go back and we can look and see exactly what happened and do a forensic audit to understand where the problem was and go patch it up. So responsible AI, this is a very key element here. As you're doing a new technology, you have to really help customers understand and get on board with this. If you go back, 20 plus years, you remember when cloud was becoming a big thing, customers were very nervous. People were very nervous about putting their data on the cloud and moving to the cloud. They're like, well, what do you mean my things are going to be outside of my control on this other public cloud like Amazon? And so you had to work with customers to make them understand how secure things still were, how protected everything was, all the security in place to ensure what's going on, and get them comfortable doing that move. And the same is true with AI today. So there's a lot of customers, they have the spectrum where some are eager to use it and some are very nervous about what it's doing. Is my prompts being used to train the models? How's my data being protected? So these are some of the pillars we look at responsible AI. Fairness is a big one. We want to be sure we don't reinforce bias, making sure that the data we're using to either fine tune or use in the RAG system is unbiased data. Explainability is another big one, because we want to make sure that we can understand what's happening under the covers. As we showed with the RAG example, we have explainability through citations and other ways that we can look at where did this answer come from? What data was used to generate this particular answer? Security is another paramount one. Like I mentioned, we want to make sure that people understand that their system is protected. We have three areas where we use security in the generative AI systems. One is the overall system security. So make sure our VPCs, everything is all protected and locked down. We also have application level security to make sure our applications are protected. We're using data that's encrypted at rest and at transit. And then we have data protection as well. So we want to make sure that as we're using LLMs, we don't let customer A be able to jailbreak the LLM and access customer B's data. So all of the security we placed around that allows customer A can only ever see customer A's data. So the system itself will determine what data the LLM can use. That way the LLM doesn't have any determination and any decision making in which data it's going to pull. And so that keeps that secure. So customer A is protected, customer B is protected, and they're partitioned. And transparency. And we want to make sure that we're open how we're doing things. We have a white paper that we give customers. It lets them know how we use AI, how our AI models operate, and the processes that we have in place to make sure these things are protected. And then privacy, like I mentioned, they want to make sure we're not using their data in our models or their prompts in our models. And so we assure them of that. And that goes part of that transparency. We explain how we're using data, what we're doing with it. And it gives the customer confidence to know that their privacy is paramount with us. So now if we take a step back, we look at just our overall tech stack. So outside of just generative AI, Clearwater, as I mentioned at the beginning, we do a lot of things. We aggregate, we reconcile, and we report on all the data that we have in our system and all the $7.3 trillion of assets under management that we have. So Nextla, part of this, is really the ingestion side of it for us. So we use them with lots of different connectors. We can connect lots of data sources. We can pull in lots of different data formats. We ingest all that data into our system, and we go through the Clearwater processes of normalizing it and enriching it with all of Clearwater's information and Clearwater's data. Then we process and calculate it. We're doing lots of accounting and aggregation and other calculations on that data. And then we store that off and build it for reports for our customers. So statements, reports, and other things that they can use in their accounting and in their business.
I'd like to extend my heartfelt thank you to all our panelists for joining us today, sharing their valuable insights in the world of data integration. Thanks to each one of you for the questions that you asked. If this was something that you liked hearing today, please join us for a free data integration summit on May 7th for more great speakers from companies like Silver Lake, Bayer, T-Mobile, John Deere, and many, many more. Before we sign off, I wanted to share a quick introduction about Nextla. At its heart, Nextla is helping solving challenges of getting data from multiple different systems. We have automated different aspects of data integration, which includes solving three big V's of data integration: the volume, the velocity, and the variety of data. What we have observed is, as you try to get data from more and more systems, the variety of these data items increase. The volume of the data is increasing day by day, and the velocity at which these are coming wants to be as close to real time as possible. On the consumption side, there are more and more data hungry applications. You need data to be used by an AI model. You need data to be used by analytics service. You need data to be visualized. So there's this deep difference between an impedance mismatch between a producer and a consumer, and Nextla helps you automate a lot of that to be able to make data ready to use in a very, very short span of time by using the techniques of automation. Just a quick glance at how some of our customers are seeing this. Typically, we see a 5 to 10x reduction in cost and bandwidth for data engineers. We see infrastructure cost reductions. We see about 75% improvement in reduced timelines, and we also see a 50% increase by using our reusable templates out there. How do we solve this, and why this is a big problem? We think that the data integration needs and the data integration teams, there's a kind of they are a sort of an inverted pyramid. With Gen AI, there is more and more demand for analytics, AI, and operational use cases. These use cases keep coming more and more, which brings companies further away from time to value. And we think there are two approaches that help us solve this problem. There's the approach of automation and collaboration. With automation, we are able to automatically generate connectors. We're able to automatically model data, and we're able to scale those data pipelines that are being built on top of Nextla by using our metadata intelligence stack. Collaboration is the play where a data user, somebody who understands data and somebody who understands data systems can collaborate in a no low code type of an environment. This is a place where a developer can write a very complicated logic, but a business user can come in and use that logic without really understanding what's happening behind the scenes. So that abstraction sort of helps them. Let me just do this also once more. So, so we think the demand versus capacity for data integration is an inverted pyramid. With Gen AI, you need to bring data from more and more systems. But the people who are responsible for doing this, the data engineers, the data infrastructure team, their size is more or less fixed, and you cannot really hire your way out of this very easily. There is more and more use cases which are going to come, and which will bring companies further away from that time to value. We think there are two big parts of these challenges, and they can be solved together by using these techniques of automation and collaboration. What automation gives you is this ability to automatically generate connectors, to automatically model your data, use the metadata to scale your pipelines more and more. That solves the infrastructure part of it. Then there is the people part of the problem. There is this disparity between people who understand data and people who understand data systems. If we can have a platform where these two users can collaborate with each other, where somebody who understands data systems can come in and write a very complicated logic in full code, but then somebody who is a business user can use that complicated logic in by using a couple of clicks, it helps them to come together in a tool and be able to solve this problem together. How this materializes in real world, it's a very very simplified diagram of what happens under the hood in Nextla. On the left hand side, you have thousands of systems that we have built-in connectors to. Our layer of metadata intelligence is able to connect to pretty much anything out there and generate a constant looking data product out of it. These data products can be combined, joined, filtered together in order to create more consumer view of the data products out there. And these consumable data products can be used in very, very different settings. They can be used in operational systems to operationalize a use case. They can be used by visualization tools via the analytic data warehouses. They can be used for generative AI for putting data in a vector database. A data scientist can get access to these via an API or in Jupyter notebooks. These can be shared by within a Snowflake clean room or an API or a file system. What this does is your impedance mismatch between data living on a different producer system and your consumer system can be solved by Nextla using this concept of metadata intelligence and automation and collaboration that the users do in the platform. Very quickly, we'll talk about Daryl talked about Gen AI as a use case. What Nextla is able to do is it's able to get these three types of pipelines work together. These are very very different pipelines. You have a batch pipeline, which is used to ingest documents into a vector database. There is a real-time workflow to do vector search and to enhance it with context, and then use that for prompt enrichment and use a model from a OpenAI or a Llama or a Mistral. Nextla is able to do all of these use cases within one tool, and we can with exactly the same interface. The user doesn't need to now learn a new interface to do batch, streaming, or real time. All of these can happen in just one system.
Thank you everyone for joining us today. I'm sure you loved the sessions today. If you liked what you heard and you wanted to see Nextla in action, explore our product tour, request a demo, and somebody from Nextla would love to walk you through this. Thank you.